little sparser because of the party last night. I knew that was going to happen. I was back in my hotel room hacking on slides. All right, apologies to people who were at EuroPython. I've added a couple new things, hence the hacking in the hotel room. So I am an NLP person and do lots and lots of backend NLP modeling right now. But I did do for a number of years a lot of data visualization, and so the side projects I'm going to talk about involve a lot of visualization, partly because I just wanted to keep playing with front-end, like, pretty stuff, and you get an immediate feedback when you get something live on the screen that you can interact with in a way that you don't with an NLP model. I give invited talks occasionally, and when I do that, I usually make a new talk. So again, apologies that this has overlap with this week's talk at EuroPython. So the toys I make are toys. They're like fun distractions. They're not like professional code. I'm trying to get better about publishing my toys so that people can see how I did them, even though they aren't really like professional. But one of my motivations in the past few months, I've been working on really depressing stuff with hate speech and offensive speech. So I've been sort of trying to figure out how to keep myself entertained in my off work hours because of the fact that my work hours have been a little dark sometimes. I really recommend Austin Kleon's Keep Going, which is about finding your creative spark even in bad times. The problem that a lot of people have in the tech industry is that their creative spark and their job overlap more and more. And like if you're like me and you like hacking for fun, like that ends up being, oh, I could use this at work. And then they start bleeding together, and that's not always healthy. We need to like sometimes just keep a separation a little better. So these two books are really good for thinking about that separation. So the first project I'm going to talk about is kind of a data analysis, data visualization project that was based on finding something I really liked on Twitter, the Bosch bot. So you probably know about Hieronymus Bosch's The Garden of Earthly Delights, which is a really massive painting. It's got 3 panels. On the left, you've got like a Garden of Eden scene that's like a little bit restrained. In the middle, you have, I guess, people having real lives, but you'll see what those lives look like in a minute. And then over on the right, you've got Judgment Day, End of the World, sort of hell, which is actually pretty hilarious in this painting. So giant, giant picture. So the Bosch bot is a bot that posts a random little segment of that picture that you can look at zoomed in and see that detail in that giant painting. So it's a wonderful, like, small data in the big data visual bot. It's fantastic. And so it gets lots of faves, like lots and lots of people follow this bot. The way it works sort of in the middle of your Twitter feed of horrible Trump news or Brexit news, you've got this cute picture, you click on it, and sometimes it's a well-composed snapshot that could be a postcard, and sometimes not. You fave it. So my question as I've been following this for months was, so what are the segments of this picture that people have faved the most? Just a general data science question. So I made an app. It obviously, as many side projects do, sort of grew and turned into other things. But the essential steps that I did, just so that you can see like how fun was this as a side project. So the first thing I did was I used a library called Twint to scrape tweets. I've used lots and lots of Twitter libraries. This one's great because you don't actually need to use the API. It's just a scraping tool. And it's really has a great command line interface. It's just a pleasure to use. It's fantastic. So then I used pandas, obviously, to load, review, and get the top 10, which was what I was curious about. So this is like 6 months, well, January to May of data. What are the top 10 most liked segments? In the original Bosch bot posts, it was just the image. So I was faced with, if I want to visualize this, like one of my questions is where in the image were these little segments? That's actually a really hard problem. Everybody out there who works on image problems, and there's a lot of people here who probably do, will know about OpenCV and various tools to help you find where an image is in another image. We'll talk about that in a second. So then I used Leaflet.js for a web app to display them, which I'll also talk about in a second. It's not an obvious choice. So here's the app I made. Let me just demo it so you can see. Looks exactly like the screenshot. All right, so what we have here are the top 10 things that people liked. In this particular display of this, the bubble is the number of likes it got. So over here is the #1 bubble, right? I added this color thing here, which I don't love, but that's like how long has it been up? Because I had a theory that things that had more likes had been up for longer, and so they just got more likes over time. But this is not dark red, it's light. So it got a lot of likes really quickly, whereas these are older, okay? So if I click on one, I can go in and I can see that's the actual little image segment that got the likes, the little, like, that hell landscape thing. Okay, so let's go back. Here's another good one. So see, you laughed. That's why this is a fun bot, and that's why this is a fantastic painting, right? So when that shows up in your Twitter feed, you click like. Okay, so what was the #1? It was this one. Again, laughs. That's why it got faves, right? Okay, so let's go back to talking about this. So essentially dealing with this, like, okay, it's easy to just get the little top 10s and say you're done, but if you want it to be like a big picture and see where are the sections that had the likes, it turns out to be kind of big data. So the actual Wikipedia high-res image, Wikipedia has mega high-res, which I'm not even dealing with, but it has this 223 megabyte big one, which is the one that I'm zooming in and out on. That's big data. Like just loading that and not doing anything special with it took a while, and then moving around takes a while, and et cetera. Now, the other thing that's interesting, when I started trying to figure out where are the little segments in the big picture using various Python tools or image processing libraries, Pillow won't load it. You get like errors about decompression bombs and things like that. Very, very scary errors. It turns out later I found out how you can turn that off, but essentially I was like, whoa, we're in the real world, man. And then all the algorithms I tried, I have a notebook full of me trying to figure out how to register the little image in the bigger image. Crashed my laptop, ran out of memory, took forever. Now remember, I could have like uploaded this to the cloud and like thrown like lots of resources at it, but it's a side project, right? Anyway, I might still go back to doing that, but essentially all of the algorithms I tried didn't work well on this. Part of the reason they don't work well is that this is not a photograph, it's a painting. So the lines on the features are blurry. And there's also paint chip like things going on everywhere. So you have all these extra artifacts that make it even harder that the algorithms are confused by all the paint chip stuff. And so they highlight those as features. But if anyone's good at doing this with a neural net, I'd like to talk to you afterwards. So I ended up actually finding where the top 10 were by hand in Photoshop, which is embarrassing, but it was super, super easy because Photoshop has tools that will let you know where the XY is and the width and height of a segment, and then I just like overlaid and did transparency and figured out where they were, and rescaled, because sometimes these things were not the same scale, which is another reason that it's hard to figure out where, with code, where you are in the image. So, so I said I used Leaflet to display this thing. Why? Leaflet is a mapping tool. Like it's for making maps, tiled maps. Tiles are how you handle the display of the really big image. So a map is essentially multiple zoom levels. And at each zoom level, you have different sized breakdowns of the big image. And the library that you use, or Google Maps or whatever, handles the transparent zoom in and out pan across by loading the right tile at each zoom level. Leaflet's really good because it's been around for a long time, so it has a lot of tools for doing UI with big images. What I had to do was to essentially make Leaflet treat this like a map. So there's like weird code in here that changes from like a Mercator map projection to just a raster image coordinate system. Leaflet now has added tools to handle big images like this without needing to do that translation, but I did the translation with someone's library. So to convert your big image to map tiles, there's something called gdal2tiles.py that has lots of nice command lines. There's a bunch of explanation of how to do it. So after I was done, I had at the top level, the 0 level, I had one image, which is the big picture you see. And at the bottom zoom level, which is 7 for me, I have 7,906 images. So it's broken up into all these little tiles. Okay. And then you have all the intermediate zoom levels with different numbers of segments of that image. So the other thing about using a library like Leaflet, even though it's a mapping tool, is that it has tons of stuff for like a rollover tooltip that I can pass data in. I can click on it and then get into a different display where I show a different marker, which is the like square bordered thing that shows the actual image. And like I said, that was the #1 fave. So at a certain point, I got in touch with the author of the BoschBot, Mr. or Ms. BoschBot herself. And I was like, look, how are you making your little image tiles? Like, which resolution did you use? Like, I just needed to know what's going on here. It turned into a really productive and interesting conversation, and this came up. So it turns out that that is the pinned image on the account page, and so that's one reason it has the most faves. People go to that page for the bot, and they see that, and they fave because it's hilarious, right? But the other thing is that a celebrity went there. So he or she and I did not know who this was, but there's like this Hollywood celebrity comedian who went there and retweeted that image, and it became viral. And like, so he has like, or she has like, the BoschBot has 35,000 some followers now, partly because of Karen Kilgoroff. So again, unfortunately, because it's social media, just because someone faved the picture doesn't mean that it's because that was the coolest picture. Although obviously, a fat butt guy on a fish is the best picture, still. So because I was talking to the BoschBot about this problem of trying to figure out where the image was in the big image, they added the actual like coordinates and the width and height to the posts. They aren't as pretty, and they might end up putting them into a SQL database that I can use in the future. But having added them, I can now work with them. So this is what I was doing in the hotel room last night. Since they added them to the posts, I scraped all those, which is like a month and a half or a couple months. And this is where the likes are, where the images were and where the likes are and how old they are. So there's no longer a pattern really going on where there's more likes going on over on the right panel, which is what I saw in the top 10, but 10 isn't a big number of data points, right? So this was my first look at this, and I was like, wow, this is sort of out of control. And then after a certain point, when you zoom in and you start seeing the borders and you see how much they overlap and the transparency isn't working, this is where I went to the data viz UI UX position of this needs a new redesign. Like, this is just not the right way to show this because it's not 10 points anymore. This is now something that needs real app controls to filter, to handle the volume differently. I did make one adjustment that made it slightly easier to look at, which is this. Instead of just doing color by days posted, I did the ratio of likes per days posted. So essentially, like a dark red one had more likes per day. And that allows certain things to pop up that are more interesting, potentially. So I'll do a quick demo of that one. So this one, for instance, is that. Now, as soon as I clicked on that and saw that, I'm like, of course that had a lot of likes. Like, it's obviously hilarious. All right, but so here's a home button, by the way. But the code work in progress, I haven't solved all of the resetting of boundaries and things. But so over here, we have another one that's really, again, like, of course that had a lot of likes. It's awesome. So, whereas like, I don't know, a more random one, that's obviously random. Like, it's not as cool as the ones I just showed. So in a sense, the bigger data with the more votes and the likes per day is actually paying off. But it's not a finished app. That's in progress. Okay, so some related work, if you're interested in big image display. The Pudding, which is a data visualization publication that does great work with and makes original data sets, they use this tool called OpenSeaDragon to do their sort of tiling, panning display of best-selling book covers. The library is cool. It's just that because it's not like a library that's got a lot of UI tools with it, all it does is the panning and zooming, right? You don't get any tooltip stuff, or like you essentially have to add stuff or add extensions or write your own stuff. So it's quite cool. This, by the way, is a TS&E layout squarified using Roster Fairy from Mario Klingemann. So if you're interested in that kind of display, the links are in my slide here. Okay, so let's talk about another couple of things. So I'm an NLP person, and I'm interested in visualization, obviously. Word2Vec is more visualizable than current transformer-based embedding language models. So I've been playing a bit with Word2Vec over the years. So lots of you probably know the details. Word2Vec is essentially this concept that it encodes in a matrix the context of words used in a corpus. It's actually a very simple language model. These embeddings, they aren't particularly strong at understanding how to deal with words in different contexts, which modern transformer-based models are. So I use Project Gutenberg a lot. It is fair use out of copyright text, and it's got this like old 1980s style website that's really horrible. But everything comes in multiple versions. So there's like a Kindle version, plain text, EPUB, HTML versions. So it's a great place to get text data if you want to do modeling. Now, there are a bunch of libraries, including a lot of Python libraries, for getting text off of Gutenberg in a more automated way. I actually use David Robinson's Gutenberg R package. It's a little out of date, I should warn you, but among all of the packages I've looked at, that's the one that allowed me to query by subject. So if you want to do things like get all the fairy tales, all the detective stories, all the ghost stories, you can do that using this package. But you have to update it. So that means you have to download the latest metadata tables, rebuild them, and I had to actually change a little bit of his code to be able to get the right info out of the tables. I'll probably talk to him about getting my changes in or forking it or something, because it's a really useful library. So if you haven't done the building a Word2Vec model, the simplest way to do it is to use GenSim in Python. This is the relevant bit of code if you haven't done it and don't want to look for an online tutorial. Essentially what GenSim wants is your corpus has to be tokenized sentences. So you need to have everything, a list of, or some generator that's going to yield tokenized sentences. And the training a model is super easy. Obviously, there's parameters you can set here, like the window and things that you can play with. And then you can get access to the vector for each word. You can do things like get most similar, which we'll see in a second. The key things here are saving the model and loading the model. So if you want to use your model in other contexts, you're going to want to be able to save it and then load it. So one of the things a lot of people do with Word2Vec is make these two-dimensional cluster plots to show that essentially words that are used in similar contexts end up clustered together. So this is just a quick demo to show you what it's like playing with one of these. So this is the fairy tales and folk tales that I collected for a model. And I ran UMAP, and the code is linked off. I put up the gist that I used. The code is linked off of the slides. So you can make one of these really quickly yourself. So for instance, if I zoom in, this is Plotly. If I zoom in on these, you'll see that there's a lot of like number words grouped together, 13, 7, 18. So what this means is that actually the model's not too bad. It actually figured out that all the numbers occur in similar contexts in folk and fairy tales, right? 5, few, 50. Over here, previous, 15th, 19th, 4th, 2nd, 1st. Okay, let's go back. Over here, we have easier, more, greater, bigger, harder, which is great. Brighter, deeper. So frequently you end up with words that are same part of speech together. Over here we have like old-fashioned words, seest, hast, mayst, shalt, etc. So there's some pretty old-fashioned texts in this collection, as you might imagine. All right, the lighter ones are words that occurred more frequently in the corpus, because this script it's a script from Peter Baumgartner that I added to adjusted. It counts up how many times the word appeared in the corpus, so you can see the more common words are lighter colored here. Okay, so here's the link to the gist. So one of the common things, obviously, with Word2Vec is that you can find most similar terms. So in this particular person's example, we have the word polite, and the closest words with a distance score are courteous, friendly, cordial, professional, attentive, gracious. So essentially what we're doing is looking at usually cosine similarity in the matrix. You're looking at like relationships between vectors. Sorry? No, never mind. All right. So essentially what I was interested in is what if we just sort of chain words together? This is the toy part. What if we go like closest word to polite, which is courteous, and then look up courteous? What's the closest word to courteous? It's obviously not going to be necessarily friendly. It's going to be potentially something else. So what if we just keep chaining like that and then look at what those word chains lead to? So I made an app. So this is the word fire. Sorry about the size for you guys. Let me see if I can. So it's easier to see, but it's not as pretty. So if we look at the word fire, the closest word in this model, which is a Gutenberg poetry model, burning, folded, lids, curls, etc. Let me go back to glossy, velvet, etc. So we read it like that, which is what that swoop is supposed to show. And the distance here says that folded is further from burning than curls is from lids. Okay, so what we're seeing is how far the distance measure says. And we can do the same thing in a different model. So this is fire in a Gutenberg poetry model. This is fire in a poetry model that includes more recent work. So let's take a look. We have a closer word. Flame is closer. So we've replaced what the closest model is when we added a bunch of works to the corpus. And we get different distances in different words. So this is wind, storm, rain, wind, mist, sunset. As I said just now, so the vertical distance represents the distance in the vector space, that score that you get when you do most similar. Size is how often the word shows up in a most similar search. So I wanted to rule out cycles because they're really boring to look at. They aren't interesting informationally. So all I did was if you get sunset as the next most current word, I just go back to the first occurrence and increment the count and then increase the font size, right? And the color here is just to be pretty and to sort of show that you're reading from left to right. So, like I said, there are two poetry models. So in January of 2019, a huge number of really interesting things were released they came out of copyright and were added to Gutenberg, including a whole bunch of really important, cool poets, like modernist poets. So the model actually changed a fair bit. We saw that with Fire. And it's really interesting to me to be able to compare those models with the extra works. So Believe, this is Believe. In the older poetry model, we had learn, grieve, suffer, choose, understand. In the newer model, after we've added the modern poets, we have suppose, believe, write, et cetera. But somewhere down here we get magazines, which is hilarious and shows that this is truly a different model. All right, so I decided at the sort of 11th hour that let's add something totally different. Let's add like Nerd2Vec is a model that you can just download off this dude's website. It's Star Trek, Star Wars, and Doctor Who, and it's super different from the poetry Gutenberg model, obviously. So in Nerd2Vec, when you search for Believe, you get discover, think, realize, continue. These are not poetic uses of the word believe, right? Now, that project I did a while ago, like 6 months ago. I updated it with these new models and the radio button fairly recently because I wanted to be able to compare model visualizations. But one of the things I was sort of aiming at eventually was using those Word2Vec models and the distances in a kind of a creativity aiding tool. So I'm super interested in found poetry and other things. So this is blackout poetry. You've got a text, you black it out, but you leave certain words visible. Austin Kleon made this very popular. This is some of his examples. He has a book on it, actually. This is old school cut-up poetry, where you take different texts and you combine words. This goes way back to the Surrealists and a bunch of other older non-digital poets. So that's by Timothy David Ray. This is an example of a poem by Reznikov that is using legal reports and taking sentences out of legal reports to construct a poem, which is brilliant. Depressing, but brilliant. So I'm inspired by these kinds of things. And I also was kind of like, well, what if I want to mess with these open source poems? Remixing and mashups are fine now. They're fair use, right? So I made a demo where, a toy where you load a poem and then you use a Word2Vec model to mess with some of the words in the poem. So let's load that one up. Let me increase the font for you guys. So this is Robert Frost. And we have different Word2Vec models here. And I'm using kind of a dumb library algorithm to find nouns in this text in a kind of sparse way. But so essentially, if I click on woods, I can pick words from the older poetry Word2Vec model and replace. So whose woods are these? Let's go with whose hills are these? And now I have a different poem, right? His house is in the village. His house is in the churchyard. I can't see because it's too. Let's make his bed is in the churchyard. Anyway, you get the point. So this turns out to be more fun with shorter poems. So I've added a bunch here. I could allow people to upload their own, but actually this one is interesting. So this is a war poem. So Carl Sandburg, the strong men keep coming on. I think I'll change that to women. Notice how in the older poetry model, kings are closer to men than women are. Ta-da! All right. Strong women keep coming on. What do the women do? So it's not always the same part of speech, right? There are word-to-vec models that are annotated with part of speech info. This one is not. They go forth. This is women. Okay, so let's change the model. This is the more modern one. It's still kings. There's just enough stuff in the Gutenberg poetry corpus that even adding the more modern stuff, women is not now we have people before we get women. All right, okay, so let's go to folk and fairy tales. So now we get women. But notice warriors shows up. Dogs show up in here. Giants, because it's a folk and fairy tale model, right? Okay, nerd to vec, women, guards, soldiers, troops. There's a lot of fighting in Star Wars, Star Trek, and Doctor Who. All right. So I actually find this kind of fun, which was the goal I was after. So the color here represents a normalized distance between the original word and its next closest relative. So essentially, if it's a pink word, that means that the next closest word in the word-to-vec model is actually kind of far relative to the others. So that means like maybe this is going to be super interesting to click on, maybe not. Now, so as I just demoed, this is largely for the slides. So you've got your basho haiku, which seem to be kind of the funnest to play with, to be honest. The old pond, frog leaps in, water's hush. It's actually water's sound is what the original was. So now this is an interesting one. So in old pond, frog leaps in, water's sound. So if I click on pond here, and I'm in the nerd to vec model, this just goes to show you how sort of weak these embeddings are. What I get is a whole bunch of proper names, because Amy Pond in Doctor Who, essentially there aren't enough uses of the word pond in Star Trek, Star Wars, Doctor Who, et cetera, for pond to be like body of water. Instead, pond is associated with Rory and a bunch of other character names, because that's how simple these word-to-vec models are. All right, so just so you understand the color thing, if you don't know about D3, D3 makes it easy to do these mappings of numbers to color ranges. It's one of the most useful things, all the scaling that you get for visualization. So in JavaScript, essentially what you're doing with D3 is you're saying my domain is the furthest away word in the word-to-vec model, the distance score, and the closest score that I got. And then I'm mapping that to this color is furthest away, this is closest. Or vice versa, depending on what you want anchored where. Now, I built this with React because I wanted to play with like a modern web framework, because I haven't done JavaScript for a job for a while now. So React turns out to be really, really a pain. I could have done this really fast in just plain JavaScript, like base JavaScript, maybe with some jQuery and D3, of course. So the app involves all these different component levels. It's like all the way down to like the select list. So you have the app where you have your drop-downs, you have the poem itself, then you have each line of each poem, you have the little like clickable words, you have the modal that pops up, you have inside the modal, you have the list that you pick with the radio buttons, and then after you choose one and you close it, you have to pass the state all the way back up to redraw the poem with the word that you chose, okay? Now, originally, when I wrote this, I put the API call here to the word-to-vec model at the modal. So click on a word, get the relatives. Like, that's obvious, right? The problem is I wanted to visualize the distances. So I wanted to have the colors on all the words so you could see that this one has a neighbor that's further away than this one. So I had to put the call up at the poem level. And then it was like, here I am with 20 words looking up all the 10 closest and getting the distances to redraw the poem. That was hard. Like, there were a lot of promises going on. It was really kind of a pain. And then in the end, I'm not sure the colors are actually super useful or interesting because the distances aren't that far most of the time. So that was one of those like data viz experiments that probably didn't pay off that well. And React, like, it is a pain in the butt in a lot of ways. So this is a guy posting, this is how you pass state down in React with 4.1 thousand likes. And this is the video, if I'm connected to the internet. This is seriously programming in React. This is what my code looks like. That's what my code looks like. Okay, but like I said, the Basho haiku are kind of fun because they're short. So here's the original version. Here's me having used one of the poetry models, the last wet shower. Even the basil seems to try a little cap of dirt, which is very pretty and cute and feels like a good haiku. The word-to-vec model, the last hot meteor, even the lizard seems to need a little robe of guts. So with the right model, you can get some really different results. Okay, so if we look at the parts of this project, so the word-to-vec models, easy, I've done them a lot. Coding the poem in React, yeah, easy to make a decision like that, but then like really hard learning curve because of all the different components I had to build and all of the state that I had to pass up and down all the time. This was hard. Changing the stack to get the distance for all the words as promises, that was super hard. Novice React programmer, remember. Doing the color scale on the buttons was super easy, and even plugging D3 into React was easy, so that was fun. So at a certain point late before the talk, I added the drop downs to change the model and to change the poem. That actually was not so hard. So that was a point where I was like, well, maybe that's why people use React, because adding components to the page or making what looks like it might be a major change maybe isn't if you've got the right framework going on. So some related work, lots of you know about GPT-2 and things where you can sort of start a text and then complete it with a word model. Hugging Face has a nice write with transformer model up there where you can play with the completions from GPT-2. It's actually only okay. Lots of things are not grammatical or don't make sense with it. I've put the slides up so you can look at this later, but this is me trying to write something somewhat sensible with GPT-2, and the blue is the completions from the model, and the white is me, and it's funny but bizarre. So still not quite sold on these things. Maybe the really big GPT-2 model is better. So in the visual space, there are other tools like NVIDIA's Gauguin demo is cool. You can sort of draw something kind of crap, and with the colors indicate whether you want it to be cloud, mountain, grass, sea, or whatever. And then it will like photoreal render it for you. It still doesn't look good. Other people are better at the drawing part of this, I think. So I've seen some really amazing seascapes or whatever, but I think like you have to be drawing something that's quite similar to what it was built with in terms of modeling. Whoops, sorry. And then one of my favorites, though, is the GAN Breeder app. So the GAN Breeder app is this cool, like, toy whatever thing. So you start on the homepage with, like, here's a cool animal. You click on one that you like, and then you can generate children and sort of control relationships. Oh, cool. And then you can crossbreed with images or edit the genes. So the genes that went into this are peacocks, redshanks, I don't know what half of these things are, gray fox, cricket, fox, squirrel. So let's up the cricketness. Let's up the guacamole. Let's turn down I don't know what that is. Make a child. Okay, so so you see that this is a guacamole cricket thing, very, very different from this. And then you can, like, fave and then go and play with these some more. So these are castles that I made because I'm obsessed with castle generation. So like, there just aren't enough architecture examples in the set. So hopefully when this person updates this tool, it's going to have even more castle generation possibilities. Yes. All right, so find, make, use cool data sets. I mean, obviously as a data viz person and a data analyst originally, I like data sets, but I think you can be, like, super creative about your data sets too. Sometimes things are data that you didn't know were data. There are, however, ways to find data sets if you don't know how to think about data as differently. Jeremy Singer-Vine is a data journalist who has a great mailing list called Data is Plural, which documents weird, interesting data sets that people have told him about or he has found. There's also an archive of data sets there. I have a giant, I obsessively collect links on Pinboard. I have one for data sets that has things that you wouldn't necessarily think of as data sets. And then, like, make your own, remix fair use content, like Robert Frost now. This is an example of a cool side project by Josh Stevens, who's a mapping data viz person. This is Bigfoot sightings in the US and Canada. Obviously, no one paid him to make this, but I'll tell you what, this was all over the news. Like, he has a lot of press for this. It's also very good data viz. Janelle Shane, so I added this recently. Janelle Shane is the kind of the hero of creative uses of AI for text generation. She's totally worth a follow. I added this because I'm in England and you guys might laugh at this. If you show this in Europe, no one knows why it's funny. This is like pubs from the north of England generated by a neural net. So, you know, we have the rat horses, We Travel, which is actually a pretty weird pub name, but some of these are really, like, could really be Old Festerland, Burn Horse Hotel, Doss of Wooling of Stank. Clearly that could be a pub, right? Loons Hall, the All House, Arse Inn. She said a lot were pornographic, so anyway, I would recommend going and reading her article about this. She gets sent weird data sets all the time, including smallish text data sets, and then turns them into gold. This is one, you would not think of this as a data set, but again, like, if you think creatively about what data is and what a data project, this crazy person alphabetized all the scenes in The Wizard of Oz. So let me just start it playing.
Big billowing, sweet twitty, bye-bye, blizzard blowing.
So the whole thing, including the credits, are alphabetized. I don't know why. I mean, but essentially, it gives you a different appreciation for the movie. And he used code. Like, of course he used code to do this. Like, at first I was like, wow, that's some insane editing job. And then I read the article. It's about code. So, whoops, sorry. I have to advance differently. So here's the point about this. He says that his appreciation for the film increased because he's looking at it as small data. Like, he's looking through every single clip and word, right? Just like the Bosch bot. And just like any fun data viz project where you have to spend a lot of time on the details of the data. So that's one reason I like the artistic uses of data, because you, especially like if you're editing a poem by Basho, you think about your choice. Like, if I'm replacing a word from a famous Japanese haiku poet, what am I replacing it with? And in the choice of a Gutenberg poetry model, I'm looking at like words that came from other poets. So it's not so bad. But there are other cool data sets out there that have been used in AI art in particular. So Victor Dibia curated and cleaned thousands and thousands of African mask images in order to do GAN generation of African masks. So that's a wonderful project. Anna Ridler took photos of tulips to generate tulips that have never been seen before. And just this collection of photos of tulips is itself a massive, massive data art project. So that's the link to her generated tulips if you want. Helena Sarin does GAN art using drawings and photography. She doesn't use other work. She uses her own work. And it's all really beautiful and really interesting. This is a poem by Mary Oliver, Pay Attention, Be Astonished, Tell About It, which I think is wonderful inspiration. This is a project that I still haven't had a place to talk about that I think is hilarious. This is data in a weak sense. It's using translation models. So each of these blobs is a speaker of a different language, and they run into each other. And they use a machine translation algorithm to convert what they said into the other language. And you get a chain of bad translations that are hilarious. This was a really fun project. The conference I did this for was canceled, and so I didn't get to talk about it. So if anyone wants to have me come and talk about this, I'd love to. But if you're going to do this, don't be a jerk. Give credit to your sources, help each other, especially inspiration from artistic sources. That matters too, right? Like, credit who inspired you. But really, like, don't be this deep nudes guy. I mean, I shouldn't have to say this, but just because if I don't do it, someone else will do it in a year is not a good reason for a project, especially a side project. What the hell? Okay, the algorithm only works with women because images of nude women are easier to find online. Be more creative, right? And now this is all over GitHub, although GitHub said it's taking it down. Okay. So I want to reiterate that, like, this is my patio in France. Like, the pots are work, right? Like, I plant all these seeds, and they're growing there, but it's essentially work to keep them alive. I have to water them all the time. It's very, very hot in Lyon. But meanwhile, like, one of my potted plants dropped a seed over the edge. This is just so ironic to me. A seed from a plant that died in a pot landed on gravel under here with no sun, no water from me. This is one plant. Take a look at it. I mean, it's like doing so well. It's doing way better than anything I worked to keep alive. Like, I just feel like a failure and a success when I look at this, right? Like, this is amazing to me. Put your stuff out there, even if it's kind of garbagey code. I'm trying to do better at that myself. Max Kerminsky, who's a game designer and fascinating character, has a reminder here. If inexperienced creators are using your tool to churn out loads of half-baked garbage, your tool is a phenomenal success. You too can have lots of people making half-baked garbage with your stuff if you want, which I do. So I went through a creative coding course, and I did this as my final exercise. It was an online thing. I posted it saying, Matt, your course was amazing. This was like weirdly popular. All it is emoji smileys. People loved it because it's fun, right? So just make things that make you laugh and share them and make other people laugh. So I would like to give thanks to a lot of people, including the BoschBot, for this. I couldn't have done all of this without the BoschBot. Peter Baumgartner's just, like, crappy, sketchy code, right, got me a Plotly interactive UMap for this talk in no time at all. So I paid it forward by updating it with some more stuff. The Word2Vec API code, I could have wrapped that Word2Vec models in a Flask API myself, but I didn't have to because this person had posted some code. I got a little help from a friend with React when I was moaning about it. And this person here posted a comment on the UMap library with how to import it if you have an import problem. Many, many people have profited from his comment. Let's all help each other out. Anyway, there's my credentials and some more of my writing about AI, art, and data viz if you're interested. And these slides are up at this URL with the links and things. Not the projects, they're all local demos still, but I'll work on getting them online. Thank you very much.